Hello everyone. Welcome to SKLEARNING C#.NET interview series. In this video, we'll explore the difference between concurrent and parallel. C# is a powerful and versatile programming language that supports both concurrency and parallelism. C# offers various features and libraries that enable developers to write concurrent and parallel code easily and effectively. Concurrency is a condition that exists when at least two tasks can start, run, and complete in overlapping time periods, while parallelism is a condition that arises when at least two tasks are executing simultaneously. Concurrency is a more generalized form of parallelism that can include time slicing as a form of virtual parallelism, while parallelism is a specific form of concurrency that requires simultaneous execution. Concurrency is more about the design and structure of the application, while parallelism is more about the execution and performance of the application. Concurrency can be achieved by using a single processing unit, while parallelism requires multiple processing units. Concurrency aims to improve the responsiveness and interactivity of the application, while parallelism aims to improve the speed and efficiency of the application. When using both concurrency and parallelism, be aware of the synchronization and coordination issues, which arise when multiple threads need to communicate and cooperate with each other. Synchronization and coordination can affect the performance and efficiency of the concurrent and parallel execution, and should be minimized as much as possible. For example, use asynchronous methods and callbacks to avoid blocking and waiting for other threads, and use concurrent and parallel constructs and libraries, such as async/await, task, parallel, and plink, to handle synchronization and coordination automatically and transparently. When using concurrency, avoid race conditions, which occur when multiple threads access and modify the same shared resource without proper synchronization. Race conditions can lead to data corruption and inconsistency, and can be hard to detect and debug. To prevent race conditions, use thread-safe collections and data structures, such as those in the concurrent namespace, or use synchronization mechanisms, such as locks, mutexes, semaphores, or monitors, to ensure that only one thread can access the shared resource at a time. Don't forget to like, share, and comment on this video. Subscribe to SKLEARNING for more informative content.